Hello Israel, coming to you again with another video. This is Red Planet. Okay, I found this video on BP Watch, Earth Watch. Talk about this asteroid supposed to be coming in November 2nd. Supposedly. Hear me say supposedly. I'm not saying anything. I'm not saying that it's coming. I'm not predicting any dates on when it's coming. So we're just going to hear him, see what he has to say. I'm not saying it's coming. We're going to hear him on what he's saying, okay? Well, let's get to it.
For the election, not a lot has changed, but I'm going to go over the information here. They saw it on November the 3rd in 2018. They first spotted it. They were able to observe it for up to the 16th or 13 days, and you can see that on the right in the data arc span. Now, condition code is very important in this video. If this condition code was 0, I probably would not be mentioning the asteroid at all. Condition code goes from 0 to 9. 0 being very good. They're highly certain of where this asteroid is going to go. 9 is being highly uncertain, guys. Pay attention. We're at 7, okay? That means they're not very sure where the thing's going to go at all. And again, if it was 0, where they were saying we know exactly where it's going, I probably wouldn't be doing this. Looking at the close approach data, it's going to approach the moon and the Earth very close on November the 2nd. Much closer to the Earth than it is the moon. If you take this minimum distance, and the reason I'm using minimum and not average is because the condition code is 7. Again, if it was 0, you could look at the maximum distance and probably be pretty accurate. But if you put this 3.907-05 into an AU calculator, you're going to see that we're at about 3,600 miles from the center of the Earth. In orbital mechanics, I'm not going to go into it. Look at the video at the very top of this channel. They measure from the center of an object, from the center of the asteroid and the center of our planet, okay? That is called orbital mechanics. That's how they do it. If they're projecting a rocket or a satellite or something in its path, that's what they do. Now, if you break this down and put it in the calculator, that means from the center of the planet, notice at the bottom, 3,632 miles. Not above the planet. Study orbital mechanics. Again, the video at the top of this channel, I go into that. Now, if you take the Earth, it's 7,917 miles wide. So if we go to the center of our planet, guys, you're at 3,958 miles. Now, how far from the center is it coming? Look at the very bottom, 3,632 miles. So if you went, that is telling you we have a 300 and basically 25-mile problem. That's minimum distance, but again, condition code 7. Not very certain at all where it's going. Now let me point this out. This would not be an impact event except for very small fragments or something this small. But there's some important things that we need to talk about. And what happens is you have an air burst. But if, again, if you look at the JPL model here, you've got the Earth. I'm going to bring it around where we're pretty close to looking at the ecliptic of the inner solar system. We got 2 passes. And so the first one, the asteroid is coming under Earth. But here in this area where you see Venus now, inside its orbit, is where it's going to get really close, and that's November the 2nd. If we step this forward, notice we started yesterday on September the 5th. We're going to bring it forward. Again, the Earth is out racing 2018 VP1 at this point. They're not exactly in the same orbit. There's a tilt to VP1 compared to the Earth. But as we approach where you see the blue line and the white line intersect, on November the 2nd, that's going to be the problem point. Again, if there's any impact, it will be fragments. Remember the Cheryl Blinks meteor. Remember that, okay? It exploded high above Russia, but they found small fragments in the ice above a lake. Again, right there. See that close approach, guys, as we go through that? That's going to be the problem date. So we got minimum distance with a 7 condition code showing all at that point that somewhere there's a 300-mile problem.
If you work in a team, you've got to try Monday.com. Go to Monday.com and manage all your team's work on a powerful platform that's easy to use. So easy. Whether it's projects or workflows, you can track.
Now, NASA says it's 7 feet. CNEOS says it could be 4 meters, which would be 14 feet. That's about a third the size of the Chereblink's meteor. They're saying up to 66 feet, so if we go back and say even a fifth of the size, we'll go from there and take a look at it. But again, here's your different variations. But guys, and you got 3 different models. But using the close approach data that I'm using, it's showing a 300-mile problem. So if we look at the Chereblink's meteor, guys, on that day I was live, if I'm not mistaken, and we were watching a different meteor that everyone was talking about. This hit on the other side of the planet from where we were watching, but it was a super bolide that entered Earth's atmosphere over Russia on the 15th of February 2013 at about 9:20 or 3:20 UTC. And they're saying this near-Earth asteroid was about 20 meters, and we're talking about possibly 4 meters, okay? So about 20% of the explosive strength of a 20-meter asteroid. It was coming in at 42.9 thousand miles per hour. Quickly became a brilliant super bolide meteor over the southern Ural region. The light from the meteor was brighter than the sun, visible up to 62 miles away. It was observed over a wide area of the region and in neighboring republics. Some eyewitnesses also felt intense heat from the fireball. Guys, it damaged thousands of buildings. Due to the high velocity and shallow angle of atmospheric entry, the object exploded in an air burst over Chereblink's oblast at a height of about 97,000 feet. The explosion generated a bright flash, producing a hot cloud of dust and gas that penetrated to 16.3 miles, and many surviving small fragmentary meteorites, as well as a large shock wave happened, guys. The bulk of the object's energy was absorbed by the atmosphere, with a total kinetic energy before atmospheric impact estimated for infrasound and seismic measurements to be equivalent to the blast yield of 400 to 500 kilotons of TNT. Guys, that's 33 times as much energy that was released from the atomic bomb detonated on Hiroshima. So even if you say a fifth of that, 33 times, think about it. The object was undetected before its atmospheric entry, in part because its radiant source direction was close to the sun. In other words, it's hard to detect something coming at you from a bright light. Same thing is happening with our asteroid. Its explosion created panic among local residents, and about 1,500 people were injured seriously enough to seek medical treatment. All of the injuries were due to indirect effects rather than the meteor itself, mainly from broken glass from windows that were blown in when the shock wave arrived. Guys, it looked like the Lebanon blast. Minutes after the super bolides flashed, some 7,200 buildings in 6 cities across the region were damaged by the explosion's shock wave, and authorities scrambled to help repair the structures in sub-freezing temperatures. Snow was on the ground. Check this video, guys. Many of you seen it. This was 2013, February the 15th. Guy pulls up to the red light. Snow is on the ground. Watch from the left. Here comes a asteroid we weren't looking for, and it exploded with 33 times the energy.
Good morning. A statement that's gone around in the fake news media. We did it.
Hiroshima. And this was over several cities. Look at the damage. If you go in and search it, guys, you can see amazing videos of doors being blown in and people thrown against the opposite wall. Again, very much like Lebanon. So this is what I wanted to talk about. We're not going to have 33 times the explosion if the condition code doesn't change. They have not relocated this object yet. That's why the condition code is 7. Maybe between now and November 2nd, we will, what they call recover it. If they can recover it looking at the sun, that could change. That could get much better. They would actually have some data to work with. But when you see a data arc span of 13 days, what they do is they measure the curvature of it and the degree of the curve. And then they just back that through the computers and they can find the orbit. So as they recover this, it may change if they recover it. But you can see what happened at one they could not see because it was coming from the sun. On the day, we were watching another one that was going to be up on TV on some of the different satellites. You were looking for a left hook and you got a right hook. Anyway, 300-mile difference on the minimum now from the center of the Earth. It's a heads up. Be safe.